Hey everybody, back with a quick video. Hopefully this is quick. I'm not sure where it's going to go, but I was able to pick up this Advin Pilot MVP, which is a much smaller form factor than the previous Advin. I think I had, a U84 before that I had since sold, but then this came up and I was able to pick it up, so I figured I'd do a quick little review, but also show a capability of some of these programmers that might not be on some of the cheaper ones, etc. So the first thing is this is the data sheet. I actually got this, I think it even came in the box, and let me see, came with the manual and everything. And the manual, I think they started making these like in the late 90s, these Pilot MVPs, and the manual was printed in 2004, so I assume that this had since it came with this manual, this is at least 2004 time frame, so old but not super old. Couple of the key things here that I just wanted to highlight. It programs pretty much everything. Now it only has a 40-pin dip socket, ZIF socket, 40-pin dips it can program with the ZIF socket there. But that's pretty much all you need for arcade stuff. And it can do PALs, GALs, PROMs, EPROMs, microcontrollers. Pretty much everything that you could think of from an arcade standpoint it can do. Goes from 2716 all the way to 64 meg EPROMs and flash memory devices. It supports all the algorithms there, standard, fast, intelligent, quick pulse, all those things per the device manufacturer. So that's one of the things that's always kind of irritates me about the TL866 and the GQ, is that it doesn't use, or say it uses, any of these programming algorithms. It might be using its own or something, I don't know. But it doesn't really declare what it's using. Let's see, for the PALs and GALs, you have a test vector function and stuff like that. Let's see, what else that I find interesting that I wanted to highlight. This is the thing that we're going to cover in this video, really. It covers, has a reverse device insertion check in case you put in the chip wrong, and it also does a continuity check in case your chip has broken legs or is missing legs, or it can't make connectivity. And let's see, 0 to 25 volts. It does support low voltage as well, so like 1.5 volts. And it says all VCC levels are supported, including 6.5, 5, and as low as 1.8 volts for your VCC. And then obviously you can go all the way up to 25 volts, which I thought was interesting, is it says in 100 millivolt increments. So it's pretty flexible as far as getting it on the right voltage that the manufacturer recommends, at least according to the spec sheet. So let me pause, put it on a tripod maybe, and then, or at least take the cover off. I already have it, so we can coming from the side. Hopefully there's not a lot of shadow here. The case is fully metal, which is good, so sturdy, and also from any interference and stuff, I guess that helps. But it is a parallel port, so you have to use an older Windows computer, something that has a parallel port. But one of the things I found interesting is there's 3 tip 41s, and I don't know if you're going to be able to see this too much, but there's 3 tip 41s there. Maybe I'll come from this angle, and really 2 banks of what are these? They're like MCE transistors. Let me see. Yeah, they're MJE like 172 transistors. So there's 40 of them, and there's 2 banks of them. I think one bank is for analog and one bank is for digital. I'm not sure, but it mentions both analog and digital voltages being available. And this said there's like this column over here is like VAC 32, and this is VBD 32. That's for the diodes, of course. And then if you can see, if I can zoom in there, says like pin 9 through 16, pin 1 through 24, 25, 32, 33 through 40, and 1 through 8. So in groups of 8 pins, they have all of these transistors, and then you have altogether 4 tip 41 transistors / amplifiers, which I assume is taking our -5 volts, our ground, probably source probably equals 12 volts, but I'm not sure. We'll put a voltmeter on here and find out. And if I lift this up, make sure I don't have any static, because it's maybe I'll come on. That's zoomed in enough for you. Take this board off. It's not powered on, by the way. You can see that there's a connection for your -5. We don't know what source is yet, and then there's a switching power supply, very small, whereas the U84 had 2 switching power supplies in there. One was like for 20 something volts, and the other one was for your -5, -12, etc. So this one in the AC is coming in here with the on-off switch that's down this way over here. So anyway, very, very simple power supply. It's all built in, doesn't require external power supply. No, the bottom of the board looks great. There's no, like, you know, resistors and stuff that's you know, bodge jobs and stuff like that. But anyway, that's what the system looks like. And I'm trying to think, it's got power supply, activity lights. That's pretty much it. So let me put it back together. No, actually, we're going to power it on and test the voltage. All right, I have it set to auto voltage. We turned it on. Let's see, come around here maybe. Yeah, 4.9 volts on the 5 volt. 30 volts. 30 volts on the source. And -5 volts. Hopefully you could see that. So yeah, the source is almost 30 volts. So it must be, it's got to have to bring that voltage down from a regulator standpoint. And I don't know where I see any voltage regulators on here. There's got to be some. I don't think they're using the tip 41s for that. That should be the amplifiers. Not sure. But I'm not smart enough to really do it, you know, figure out what everything's going on. But obviously that 20-something volts is driving some of the programming voltages for the higher voltage pins. Maybe it does get amplified, because maybe some PALs actually require even more than that, or I mean, some bipolar proms might even require more than that from a voltage standpoint. But anyway. The source was around almost 30 volts, and the +5. I might actually want to adjust that +5 volts. I might mess with that. All right, I took off the main PCB there and put my voltmeter on auto volts, which puts a little bit of a load on as well. And then we'll turn it on here. And I adjusted this pot down here until I got a perfect 5 volts on the auto load. That's with a little bit of a load, and then without a load, like around 5.08. And then we'll check the -5 volts, -5.0, and almost exactly 30 volts DC on the source voltage. So that little switching power supply looks pretty good. I'll put it back together and let's test the chip. I was interested in figuring out where the voltage was coming in at. On these tip 41s on the collector side is where the source voltage of the 30 volts comes in. And I guess the 5 volts and maybe the -5 is for some of the logic chips. But this is definitely for these tip 41s. Is getting the 30 volts, and I'm not getting anything on the emitter or collector relative to that. I don't know. But anyway, I was wondering where the voltage regulators are, and they are right here with some DACs as well. So you have a MC1408, right? MC1408P8. You have one, I think 4 of those, and then you have an MC1723. There's like 3 MC1723s, which are voltage regulators, and then these resistors are probably different values that are controlling the different voltages that those regulators can put out. So anyway, somehow these tips are getting activated, and then depending on what voltage is needed, I guess, then it's being switched to the voltage regulators, I assume, and then they're driving what voltage goes to what pins. That's my layman kind of explanation. But anyway, it's still pretty cool. I just think it's neat how this board is laid out, and it's all kind of just regular type of TTL and amps and voltage regulators. It's not like some complex computer circuitry, I guess, for the most part. But alright, so I'll put it back together and then we'll show you why I started the video. And the reason I started this video here is I was erasing some EPROMs and trying to blank check them. Let's see if I can get this focused in. Upside down there. What is this? A Fujitsu 27C64. And what this programmer does, put it in my reader here. Hopefully you can see this okay. Alright, without too much more effect or something. Alright, so yeah, what this programmer does is, if you look at your options, I think, or preferences, where's it at? It has what I mentioned earlier. It has a continuity check, so it can check whether the programmer has continuity with the pins, and it has a reverse device check, so in case like an overvoltage type of check or something like that. And so when I went in and put it, let's see, do I have the Fujitsu 27C64, and then I do a blank check. It says continuity test failed, socket seems to be empty. And actually I had a few of the pins when I was doing blank checks and stuff like that, where it would say pin 15's not making contact, or pin 20, 20 something or whatever, which I thought was interesting. So what I figured we'd do is I'll put the chip in to my GQ, which does not have that capability. Let's launch it real quick, because now I'm just kind of curious. I mean, is this chip good or bad? I have no idea. So I don't know what the outcome of this is going to be. We're just filming it. And let's see, what chip? I have no chip selected. Okay, I do. The 2764, and we'll do a blank check. It says device check, blank check failed. And if I do a read on it, which I didn't do on the other one, it seems to read the chip fine. And I have, something in the buffer, a bunch of stuff. I don't know what this came from or if it's corrupted. A lot of weird stuff at the end. So what I'm going to do is erase this chip and see if I can get it to read in either one of these and blank check. Alright, so I got it erased, and then let's go ahead and blank check this thing. It says chip is blank, so it doesn't even complain. We'll do it on the Advin real quick. am I going here? Continuity test failed. I don't get it. And I know for a fact other chips are fine. Actually, let me put in a 2764, different brand. I'm not even going to change the manufacturer. So what is it about this chip? Whoops. What is it about this chip here that the Advin doesn't like? And does it actually indicate something might be wrong with the chip? You know, I don't know how it's actually testing that continuity test to the pins, but I'm thinking maybe this chip is questionable somehow. I don't know. Let me figure out how I can check this out. Just real quick, I purposely put the chip in backwards, and you can see that it gives me an error, device insertion error. So it's telling you, the Advin is telling you whether you put the chip in backwards or something's wrong with it. Whereas the GQ4X, and I don't even think the TL this TL866, I don't think that does that either. I'm not sure. Can't remember. But anyway, it was just another interesting thing about why I like these old school programmers a little bit. I mean, it's doing, maybe this is idiot proof or something, but the fact sometimes you think you're programming a chip and it'll fail, and it could be because of continuity between the pins. And like some people will like put the chip in like this, and kind of slightly, as it's latched in there, kind of just move it a little bit, because sometimes the ZIF insertion socket doesn't make good contact with the pins. The other thing is that these old programmers, these are all gold-plated ZIF sockets, and these are something else, maybe zinc or something, I don't know, but typically not as robust as the old school ones. This was around $800 and something, brand new list, and obviously you can pick them up sometimes for less than $100 or more, and this is around $100 and something as well. So, and then I also have the TL866, which is definitely cheap. It's like $50, but you can do a lot of chips with this, just not too many. I don't think you can do PALs. You can't do bipolar proms. This thing right here can do bipolar proms, GALs, PALs, all types of EPROMs, including 25 volt EPROMs. Can't do tri-voltage stuff, but for the most part, this thing is, I think, is going to be my keeper, I think, out of all the ones I tested. So I will pause here, and if I figure out what to do with that chip, I'll come back. Otherwise, thanks for watching, guys, and this is probably going to be the last. Oh no, I'm lying. All right, so the first thing I did is I went ahead and tried to program something on the 2764 using the GQ4X, and basically I failed at 6% right there, or 8% or something like that, if you can see that. So now, and now my speed was 2, so maybe I'll erase this again. I'm going to try to write this. My speed was 2. Usually I'm on 21 volts and stuff like this, slow the speed down to -2. I think that's what it actually says. So let me re-erase this chip again. It says speed should be 5. So go down there. Alright, I'll be right back. Let me erase this chip again. Actually, instead of erasing it, I am just going to try to write it again at a lower speed. So the parts that we did write should write right over it again. Maybe. Slow down the speed, it's writing it. Let's see what's going on here. Hopefully that comes out okay on the video. Yeah, it definitely looks like it's it's stuck. And so one of the things with the GQ is you don't know like how many times it's trying to write that byte before it gives up. It looks like it gave up, and because I have double write on, don't I have double write? Yeah, double write. It's trying to write it again, but it's going to stop at the same 6%. So I'll pause here. I'm going to erase the chip again, and we'll try it. I got the chip back in there, and it is blank. I just read it in there, but just to show. That it is blank. And I'm not going to try to program it with this one. I'm going to program it with the Advin over here. See if we can get it to program. Put it right over here. And close this out. Alright. So we know that this doesn't like it for some reason. It says the socket seems to be empty. So let's go to our not options. What is it? Operation options. We're going to disable continuity check. We'll do a blank check. And it says a blank check is done. And let's load a file. And get the right chip. Yep, we're going to write it. And it failed right away. So yeah, so I think this chip is bad. I mean, 2 different programmers couldn't program it, and this one had it failing that continuity check. So I would say that this chip is bad, but the difference is that this didn't give you any type of indicator that the chip is bad. It just fails to program, whereas this one, you know, failed to program like almost right away, which was kind of interesting, as well as it did that continuity check as well. I wonder if it failed at the same location. Address 17. Address 117. I don't know. I have to go back and rewatch the tape. Alright, and I was going to say that this is going to be the last video in this series, but I am working on one more thing. So I've been recording a whole video. I haven't published it yet on trying to get this BP Microsystems EP1140 working, and I have not been able to get it working, and I don't know why. I mean, I've been doing all types of troubleshooting, but this is the inside of it right here. It's got like a transformer, so it's definitely a different setup. Bunch of DACs and stuff like that, and a whole bunch of gals over here and stuff. But anyway, that is a video that hopefully will be coming if I ever get it working. But other than that, I just wanted to show my new Advin Pilot MVP 40 pin, and this thing is probably my keeper. I really enjoy it. I like the software. It's this and the Needhams are probably my favorite so far, but the Advin, because you don't need any adapters and stuff to do proms, and this thing right here will do everything I need it to do. PALs, GALs, 25 volt ROMs, bipolar ROMs. So alright guys, that's it. Till next time.